Are you there?
Yep. Do you hear me?
Okay, press the button on the bottom.
Just about, okay.
Okay, there we go. We're live. And then go to the YouTube channel for the account.
Okay. This is confusing.
It's going to be easier if you do it more times. I think this is a lot better because then we can reference them. You know?
Okay, I'm on the YouTube channel.
And then go to videos.
Videos. Not live events?
It should be the first one on there. Hey, can you share your screen?
Okay, give me a second. Where am I? This is so confusing.
Okay, go to, whoa, scroll up.
And it's lagging.
Okay, go to videos.
Alright, so we
down there.
finally got this working, alright.
Yes?
I've already told people on the actual event thing, the event chat, that we're doing the live stream, so they'll go and watch there.
What's going on?
What is?
Get the
Nothing, just don't do anything, Matt. It's still working, don't worry.
It's working?
Yeah.
Where's the video?
It won't show up on yours, it'll show up on everyone else's.
It's not on mine. The YouTube video isn't, I can't find it.
Can we
It's on the
watch
community.
maybe?
I'm actually watching it right now. It's pretty good.
It's pretty good. 5.
Did you get it?
Oh, it's lagging, right?
Alex, have you seen the post?
Yeah, I saw it, but you need the link to the YouTube.
No, all you need is to click that post that Matthew put on the community.
Okay, so it's not working on my below.
It's working. It is, trust me.
Okay.
Just click the link and it'll come up in a little window.
That was fast. I am on different.
Okay, we really need to start it sometime soon.
I can see it.
Okay, that works. That worked. It's good.
Alright, I'm gonna be deleting a few of the posts, okay?
Yeah, delete some of them, and then you guys have fun. And make sure you keep the video, though. It should automatically save itself, but just make
You
sure
aren't gonna be in it?
What?
You aren't gonna
How do you keep
participate?
Probably not, no. I have some other stuff I have to do.
Alright.
Okay, cool.
Alright, see ya.
See, man.
Alright, Matthew,
Okay.
start adding, like, lots of people. Only you
I
can do
invited
it
the whole
because you're
community.
the mod.
Just invite everybody again.
Just invite people who you think will actually talk.
Let's see. Who
Johan,
wanted to
if
go?
you don't want to talk, you can go to the YouTube link on the community.
YouTube.
Yeah, but it's like really slow, so.
It's
No, it's laggy, but it's gonna ultimately it'll save us like lag. All right, there he goes. Start adding people, dude.
yeah, I am.
All right.
Ryan. Is Ryan here?
Yeah.
Go on your. Stay in my list. Should I just invite the people who are gonna talk?
Wait. Okay, I'm gonna add Ryan right now. He wants to talk. Okay, actually, you invite Ryan.
Partial.
No, not all those people.
Few more. Michael.
Dude, no, don't invite everyone at once. Just add like 1 or 2 people.
They're gonna come. Wait, is Avinash? Who's here?
It's only me and you, okay, right now.
Okay.
Now go ahead and add Ryan.
I'm gonna kick off all the people who probably won't speak. Let's say Abraham, Michael. Does Michael speak?
Huh?
Why damn.
Actually, give me a sec. I know how to do this.
Steve, Bob.
The
Okay, I invited everybody.
people who you think will. Harshal's not going to speak.
Marshall's not gonna speak.
No,
Well,
he doesn't. He doesn't do any of this stuff. Did you add Ryan?
Yeah. You should be joining momentarily. Let's see. It's glad that Amelia have people writing onto the thing. That's probably just mainly why. Let's see. Who's that?
It's Ryan.
Okay.
Okay, awesome. You guys want to start when we get around 5-6 people?
Alright, guys.
We should start soon. Since it's live, we can probably just start and have everybody read video afterwards.
Yeah, we can, like, discuss and then also write on the review at the same time.
What review?
Okay.
Oh, the online review, the thing?
Yeah, that one.
Can you guys see my screen share?
Yeah.
Okay.
Wait. How come you guys can't hear me?
I think it's...
So this is... You saying? Okay. It matters study hangout for 9/25/2014. On the test, according to Miss Data,
Ryan,
will
just
be
restart the
short.
call. Like, exit the call and come back in.
FAQs, as you can see on the document. And we'll be discussing sig figs, problem, the questions in the problem, and the learning guide. That's probably that'll be all on there. Anyway. Vanash.
Yeah, Vanash.
Start?
Okay.
You want to wait for a few more people, or...
They might be watching the live stream and we might not know.
Yeah, let me check the live stream real quick.
How many people are watching on that?
Yeah, that's what I'm taking a look at right now.
Alright, Ryan, say something.
There's
You
4
on
people.
the Plano East IB thing, please open the chat on the side so that people can see if Ryan's saying anything.
I have a really small chat. Yeah.
Alright.
Not the Hangout chat, like the video chat. Ryan.
This is really confusing. Wait, what happened to our invite thing?
No, just
here.
refresh the page and it'll come. Let's actually start in a bit.
Oh my god.
I say 3 minutes.
Okay, so let's see.
I couldn't think I right.
Yeah, I didn't get anything. Alright.
Anything? Damn it.
For what?
Okay, I'm gonna try to invite the community again. I think the thing disappeared.
The community? Trust me, just add the few people who you think will join.
I invited the people who are coming and would talk. They're not here. I'm not sure if something's going on.
What'd you do?
I didn't do anything.
No, not.
Okay, we're probably just gonna go on these people.
Yeah.
Okay. So this is what we're doing.
Okay, what do you guys want to start with? I have the textbook open and all, so.
I think we should start from just matter in general, like the very first lesson we did on matter.
The very first lesson on matter.
I have my notes open right here, so I could start.
Alright, give me a few seconds, I'll be right back. Let me
You
go
can start with great.
Well, I mean, we've already started the document. I think we should go over that.
Matthew, just
The document's
go ahead and
good.
add the whole community.
Yeah, just add the whole community so whoever wants to join can join.
Why is
Can someone post that on a YouTube comment?
I'll do it.
Alright, I'll be back
Text
in a
must
few
look like
seconds.
this? And small, it's ridiculous. It's gay. It's gay. What is the subscript?
Yeah, it's the top one, the very first subscript.
Stupid subscript. Kid who's doing subscript right now, I'm gonna kill you. Damn it. How
Okay, so Siddharth
There it
just
is.
told me he's watching, so.
He's watching? Okay. I can't reach the thing under the subscript.
Wait, hold on. Let me see what you're doing right now. Wait, what are you trying to type?
I'm trying to get the next section open, but the subscript was being annoying.
Oh, okay. You can just turn that off. It won't, like, delete the previous subscript. Ryan, leave the call and then come back. Maybe then it'll work.
He's not on the call right now.
Oh.
And he already tried that.
Okay. Okay. So Nuhan's watching too.
Alright.
Oops.
Ryan, alright. If you can hear me, just do this. Why don't you try opening it on your phone and seeing if it works then? Like trying to do the video call on the phone. And just keep like headphones on or something.
Man.
Alright. You guys want to start with sig figs and all and then move on to matter or what?
I think we should start with sig figs.
Yeah, let's start with sig figs because they're really annoying.
Okay, what's happening with the call?
I don't know what you mean.
Oh, okay.
What's wrong with the call?
No, you just kept adjusting our volumes.
Yeah.
It doesn't matter.
Okay. Windows down. Host.
Okay, so for sig figs, how do you, what is it for addition and what is it for multiplication? Like
Okay,
how do you know
so-
how many?
Sorry, I wasn't done doing this, so,
There's a page on it somewhere. Hold on.
you, with, addition and subtraction with sig figs, okay, hold up. Yeah, it's basically the same as adding and subtracting with,
Dude, the microphone's going over.
What?
The microphone's going over, it's pausing at some point and you're continuing on somewhere else.
Oh, hold on. Let me try something.
I think like addition and subtraction, you have to find like the least precise value that you're adding or subtracting. And then with multiplication or division, it's the one with the least number of sig figs.
Wait, can you repeat that?
For addition and subtraction,
Uh-huh.
you have to figure out which one has like the least precise value. And then
And use that,
basically,
and then for multiplication, it's what?
multiplication and division is significant figures.
Alright.
The least number.
And you have to round your final answer to the fewest number of decimals in the problem.
Yeah. But, well, for multiplication and division, it's sig figs. There's like a page, the skills sheet for sig figs. It has it at the bottom.
Alright.
Alright. You also have to sometimes account for your error, or percent error, and the formula for that is A minus O over A times 100.
Isn't it just like change over original?
You think she's gonna ask that?
Yeah.
Yeah, probably. She said to be prepared for everything being on there.
Alright.
Percent error, yeah.
I'm just getting pretty much every sheet out.
It's the absolute value of what you got, like the observed value, minus the correct value, divided by the correct value. So it's like, yeah, it's a change.
Yes. I got it working, thank God.
On what? Your computer or phone?
Oh.
Computer.
Oh, nice.
Yeah.
Alright, that's good. How'd you get it to work?
I actually had to restart the Chrome altogether.
Alright.
That must suck.
So we're talking about sig figs, right?
Yeah.
Yeah, we're on 6 fix right now.
Okay.
We're gonna start with that, then move on to like just
Everything
touch on
else,
safety.
scientific notation, etc., etc.
Yeah.
Alright.
You guys want to touch on safety? It's your choice.
I mean, safety is just really basic, like just
Yeah.
knowing that you know, what all the symbols mean, and for what you need to have gloves, and for what you need to have aprons, and just stuff like that.
Know how to read like the images.
Here's a very important one. Don't forget the goggle safety sign.
Oh, I remember that.
Everyone got 3 points.
Yeah, I'm
Alright.
totally sure she's gonna take points off if we forget that again.
Guys, we can't goof off here. We're being recorded, so.
You were being recorded a
Pressure.
long while ago. I think
Yeah, I know.
So please try and make this as professional as possible.
Yes, because hopefully people are gonna be watching this after the actual recording. So that's the whole goal of this, and so that we get less lag on the actual Hangout, and more
Yeah.
people can watch.
Yeah.
All right,
So
let's start with the sig figs. Let's see this sheet.
Go to the
Do you guys
doc.
have that skill sheet, the significant figures skill sheet?
I do. I have mine right now. So
Alright, I have that out as well. Okay.
yeah. Arjun, do you want to go over it, or
I think
How about Matthew? Matthew, you go over the significant figure stuff. I'll start on the maths. I'll start on matter.
yeah, and then I'll do the one with the scientific notation.
Alright, Avinash, what do you want to do? And Ryan, just
Awesome.
Oh, what else is there to do? Really?
okay.
you want to do matter with me?
Yeah, sure. I'll help you.
Alright. Okay, so who's doing significant figures again?
One
Minus.
more thing. I just wanted to add that we're probably going to need to know the guess method.
Yeah, definitely.
Oh, yeah.
There's like 3 short answers on that.
Oh yeah, there's gonna be
Alright.
3 short answers on that, I'm pretty sure.
She gives
Yeah.
you the box.
So
Can someone type that up in the group chat so we remember?
yeah, I'll do it right now.
Alright.
So that, like, just a quick thing so that we know what we have to talk about. Like an outline.
All right.
That would be greatly appreciated.
What else is there? She said that we're gonna be given a periodic table.
Oh, really?
It's not like we particularly need the
Yeah.
table.
Yeah, but she said that we're gonna be provided one in the actual like test.
Is it,
So
is it types of unit measurement?
Ryan, if it's lagging out on you, just turn off your video. Just keep the sound on.
yeah.
Okay, so Matthew, start.
The periodic table and the pieces of paper she gave us that will be on the test has the percent error. It has rules for significant figures,
I have one question. In the beginning of the year, she gave us a little sheet with all like formulas and all that. Do you think she'll let us use that?
What do you mean?
Oh, the star.
Let me see if we can find it.
The star
chemistry
reference materials?
Yeah.
Yeah, I was talking about that.
Yeah, I have that right
I'm
now.
pretty sure she's.
I don't think we'll really need it.
Won't she be giving us this?
Yeah, she said
It's the one
she
with
was gonna give us.
the periodic table, right?
Yeah, the
Yeah,
yellow one.
it's the periodic table, and on the
Yeah.
back it has all the formulas and
Do
constants
you
and
think we'll be able
conclusions.
to use it or not?
She's gonna give us this, right?
She said that she was gonna give us one in the test, so.
Yeah, I don't know if we'll
Oh, so that
actually
we
need
don't
it.
write anything on it? Alright.
Calibration.
The purpose is probably so you don't write
Okay.
something on it and then like take it into the test.
Yes.
Alright,
She said she
continue.
laminated it too, so.
Matthew, go.
Second. Okay, so for significant figures, there are a couple major rules that you need to know. One, all non-zero numbers are always significant.
True.
Leading zeros are never significant. Zeros, non-zero digits that at least have the decimal point will be significant. And notation, the digits and the coefficient are significant.
Wait, is the number equal to 10 something that's on the form?
What number equal to 10?
When it says zeros are left to the are left of a written decimal point and are in a number greater than 10, is that like in a form? In the form she gave us?
Yeah. I'm pretty
Oh,
sure.
okay.
There's one
One more
other.
question. Is she gonna give us the whole packet for the test or just like one sheet?
We're gonna
How
get
does
the
star
whole packet,
reference
but
stuff?
we're probably gonna get the whole packet, but I think it's best if we assume that we might not and try to at least learn these rules.
Yeah.
Alright.
One of the things you might want to know is calibration. So in a couple of the questions in the problem bank and as well as the skill sheet, here's an example. The calibration of a thermometer is 1 degree Celsius. Half the calibration is 0.5 degrees. So
What is this on?
10 degrees Celsius.
Calibration.
Skill sheet.
Skill sheet, alright.
What they want you to do is to put down the significant figures relative to like 1/2, 1/4 of what they show you. If you go too deep into that, it won't be correct. But if you make it like if you're graduated cylinder and not looking
Actually,
at
this calibration stuff, it was on the problem bank, actually. I think it was like number 5 or something.
Yeah, it was like the answer was 40.
Yeah, the rulers and the meniscus stuff.
That was
And that.
if you don't like look at meniscus and like actually record it like at 42.1 instead of 40, you end up getting points off. But it should saying that you think it's like really close, but it isn't. So what you would do is take like at least half or quarter of between the and then use that as a reference point to find the closest part. So not too
use as a
far,
reference
but
point?
not too close off. Like half the calibration or something.
So like you take like half of like the marking
The problem-
distance and then.
Wait, can you like
Yeah.
can you give like an example of that?
Sorry.
Okay, on the problem bank, wait, give me a few seconds, let me actually get that out.
I'm
On the
looking at it.
problem bank, on number 5, the first ruler,
Oh, number 5.
yeah, number 5, on
Yeah.
the first ruler, how it has 0.5 and 1.
For like E, it's like at 2.4, 2.3. You're not supposed to guess something like 2.3 to 5. Automatically rounded up a lot, like up to 2.5. You're supposed to guess it somewhat moderately, like 2.4.
Yeah.
So not too far off is what they're talking about.
You can only go for the, because it's 0.5 is the first decimal point, you can only use that.
Yeah.
Wait, so you just like round it up to the nearest decimal point? Is that it?
Like I say round it up to like the
Yeah,
point
pretty much.
5 or 0.25 at least, but not so far that you
You get
go
incorrect
to
values.
2.0.
Okay, thank you.
Yeah.
Continue, math.
I think that's all for sig figs. Let me check the skill sheet.
That's all. Yeah. Good. You guys want to do a few examples?
Yeah.
Yeah.
Okay. Someone start on the scientific notation. I'll pull up a few sig fig examples and the screen share.
Do you want me to start on scientific notation right now, or?
Yeah, do it right now.
Okay. So scientific notation, it's basically one example of it is like this one right here. I'm not sure if you can see it highlighted on Matt's screen, but 52 times 10 to the second. That right there is in scientific notation. And in order to make it into scientific notation, there's a few rules that you have to follow. One of them is only one non-zero digit can be to the left of the decimal. So, you know, that means you can't have like 0 times 10 to the third because it's not a non-zero number. And it can only be one of them. So you can't have like 52 times 13. So it has to be only one non-zero digit, and it has to be to some power of 10.
So like 0 to 9.
Yeah, 0 to 9. But it can also be like, yeah,
That's just
0 to 9. Like the example she gave us on the PowerPoint was like 52 times 10 to the second. And in order to
Plus
make
4
that
times 10 to the third.
follow the rule of scientific notation, we had to add a decimal between the 5 and 2. So instead of 52, it becomes 5.2. And that way we can add it
Yeah,
easily.
so you're supposed to put it into you're
Guys,
supposed to convert it to scientific notation, then add it together,
Yeah.
Yeah.
which is kind of
And
a way of doing things.
one thing that you need to remember is if the decimal moves to the left, so if it asks you to turn some number into scientific notation, just remember this: if the decimal moves to the left, so if the zeros are on the left, then it's you count up by 1 and add that to the power. But if it goes to the right, that means you subtract 1. So one example of this could be like 100,000. If it's on there and it asks you what power of 10 is it, you would say you would count the zeros and say it was, you know, maybe 1 to the power of 5, and then you would multiply that by so you would write that as 1 times 10 to the 5th, and that's how you get 100,000. So that's just basic scientific notation, how to sort of convert that. In order to add them, all you got to do is make sure that both numbers are in scientific notation, and the second one right here is already in scientific notation because it's 4 times 10. And then all you got to do is make 52 5.2, and then you can just add them like normal, and that's your adding. And so subtracting works the same way.
Wait, don't they have to be like the same power of 10 in order to?
Yeah,
Okay.
yeah, they do.
That's like pretty important.
But by adding the decimal, what you essentially do is add another power of 10.
Are we gonna talk about sig figs in scientific notation? Because that's also really important. That was like a question on the question for this.
I'll get to that after. Yeah, I'll get to that afterwards. Next thing is to multiply. Scientific notation, which is multiplication and division are two different. So with multiplication, all you do is add the exponents, and with division, you have to subtract the exponents. So the example would be for multiplication, 3 times 10 to the second times 4 times 10 to the third, and the answer you would get from that would be 12 times 10 to the fifth. And that's not exactly scientific notation because it's not 1 to 9. So you would add decimal right there. So it'd be 1.2 times 10 to the 5th.
To the 6th, right?
No, to the 5th. Because you have to add them. So since it was
Yeah.
10 to the 3rd and 10 to the 2nd, you would make that 10 to the 5th.
Matthew, on the group chat, I posted a link. Open it up. It's actually pretty good.
Yeah, but wait,
Okay.
once you get 12, right? You get 12 times 10 to the 5th. Is that what the example says? And so you have to add a sig fig, you have to add 1 to the exponent because you got to make it 10 to the 6th. Because 1.2
Yeah.
times 10 to the 6th is the same as 12 times 10 to the 5th.
That would have raised 3. That would have made it 3 squared too, so I just changed it.
You want to explain this?
Maybe I'm just looking at the example wrong. Sorry.
Yeah. Actually, yeah, it's kind of confusing without the example in front of us. So,
Yeah.
yeah.
What example?
It's strongly recommended that you guys have the papers for these out. But just can look at the examples.
Yeah, sorry about that.
Yeah, no problem. Thanks for correcting me. And with division, all you got to do is you just subtract the exponents and divide the actual numbers like normal. So like if 50 times 10 to the 2nd, or 10 to the 6th, and then 2 times 10 to the 2nd, then you would subtract 2 and 6, and you would get 25 times 10 to the 4th because you divided 50 by 2, and then you would turn that into 2.5 times 10 to the 4th. And that's how you divide sig fig, or divide scientific notation. And I think that's all the notes I have for scientific notation. Yeah, that's all I have.
Okay.
Also
I think
mention
that's
like
Thank you
When
very
Ryan
much,
was-
Johnson.
Matthew, did you get all that down on the docs paper?
Yeah, we have multiplication.
Matthew, you just
Some
write it down and I'll
organic
fix the
scientific
formatting. I'll fix the formatting.
Oh yeah, we can add the subscript on here.
Yeah, I'm gonna add the subscript like right now.
we should also talk about that one
Yeah,
question on the quiz. I forgot where it was like addition or something, and you have to make sure that the sig fig is matched in scientific notation. I think, or the multiplied out. I don't remember.
That's available.
Ryan, can you go over the metric units and measurements?
Yeah, since it's not on the chart, we probably have to memorize at least some amount of it. Probably not going to like nanometers or something, but it you know that.
Hello?
Yeah.
Oh, sorry, I lagged out for a second there. My internet's being really bad today.
But I can't find a chart.
Ryan, just turn off your video.
Yeah, I know. Sorry.
No problem. I'm just trying to make sure that you don't lag out.
Hmm.
So if anybody wants to like add anything to what's already been said, then go ahead.
Not really. Sig figs and all that. That's pretty basic stuff. So.
Yeah.
Oh wait, like
Just looking is painful.
if you have like a number, if like you have data, right? Like let's say I'm gonna type this in the Google document. All right, it's just gonna be a new bullet. Let's say you have data and you get like 1.000 times 1, right? This is just an example.
Yeah.
To get to sig figs, let's put it like. I'll work on the example while you guys talk because it might take a little bit of time to do it.
No, we'll just wait for you to finish. I can see you working.
Basically, what you're gonna
Can
have
any of
to
you guys find like a metric chart?
Alright.
The what
Can any of you
chart?
guys find like a chart for the thing?
What chart?
Like the metric chart that we got.
Oh, I know what you're talking about. I'll see if I can find it.
Yeah, I think I have mine right here.
Yeah, but like the time it takes to copy something. Just looking at this is so painful.
Oh my god. This formatting is so bad because the shortcut is Control Plus, and every time I press Control Plus, it makes the screen bigger.
Hey, wasn't there an analogy for the metric stuff?
Oh, King Henry, or it was. I think it was King Henry enjoys lime green milk down the center of Maine.
Alright.
I think that's what it was. Let me just look that up.
Okay, wait. So, if anyone, for just sig figs
In the
and
Hangout?
scientific notation, if anyone wants it, it's basically, I'm giving an example. Let's say you have two amounts of, like, I put it in there 9.234 times 108 point blah, 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 and you get it to equal 1,000, right? You have to have the correct number of sig figs in scientific notation. Even though,
Okay.
yeah, 1.0 times 10 to the third is still the same thing as 1.000 times 10 to the third. They're not the same in terms of sig figs because those three zeros at the end actually are equating to the 9.234 in sig figs. So yeah, that's
Guys, the acronym for the metric system was King Henry drinks lime green milk down the center of Maine.
I don't want to remember that.
I just draw a chart, dude.
It
Honestly.
was the one with the most.
It's not that hard to remember.
It was the one with the most of the metric things. King Henry drank lime green milk down the center of Maine. Thank you, Siddharth. Okay.
This guy.
Liter gram.
This guy.
Liter. For matter, this is. The three types of solutions were solution, colloid, and suspension, right?
Yeah. Three types of mixtures.
Yeah. Do you think she's gonna ask us about mixtures and solids and?
Yeah.
Obviously, yeah. That's a given.
Yeah.
It's
Okay.
midday.
Can someone go over metric units and all that?
Actually, hold up. Let me. As soon as I find the sheet, I'll see if I can. I know I had the sheet here somewhere.
Just one thing about those like the sayings, right? Sometimes they
Hey, are there going to be any lab specific questions?
No.
No.
We also have to talk about intensive versus extensive.
Yeah, but that's easy. So, just make sure you remember that
EG
stuff
mean?
like
In
density.
general?
I can't find my metric unit sheet.
I got it.
You can use like an example, I think.
Essen.
Yeah.
Okay, just making sure y'all could hear me.
Alright.
Typing so hard. What is the solution, right?
So wait, do you want me to go over the unit sheet just like by talking about it, or like what?
Huh?
For the metric unit.
Metric unit. We'll highlight the three main groups that we group everything in, then everything else that move from it. Okay, so we have the liter, the gram, and the meter. For volume, gram is for volume, meters for length. Do we have weight?
I thought gram was for mass.
What?
Gram is for mass, right?
Yeah, gram is mass.
Oh, I thought you
Yeah,
said
gram is for mass, liters for volume, meters for length.
Are you kidding me?
Decimeter, centimeter, milliliter is use of 10 from each other. The full chart will be done.
And Kelvin per temperature.
There.
Can
Down all
someone
these
stop?
stuff for us.
These guys uploading pictures and everything.
Does this look weird to you guys?
What?
Yeah, it kind of looks out of
The
the.
chart. Just take out everything except liter, gram, and meter. Those are the main three, and then these are prefixes to them.
We don't need to know femto and acto, but that's good.
Damn it.
Yeah, we don't need to know until Pico.
Yeah, or we don't even need to know tera or giga, so we're pretty good.
Dude, what did I do?
I'm just gonna pull out my notes.
What is that?
So, do we want to talk about states of matter now?
Yeah.
Is this the review sheet?
Yes.
Okay.
Wait, who said that?
That's me. I'm Michael. Right?
Coleman,
Alright.
Hi.
presidency of IB.
So which sheet do you guys want to go over for next?
Head
I think
We should spend the majority of our time going over matter, because that's what's going to be mostly on the
Yeah.
Matter. Go.
Okay, let's start with the first notes thing.
Okay, so I'm gonna go over states of matter now. There are a few states of matter: solid, liquid, and a gas. There's also vapor, which I'll go into. A gas is a mixture that flows to conform the shape of the container and fills entire volume and is easily compressible. And it's naturally in a gas state, so it's not like made into a gas. The example she gave us is that steam is not a gas. It's actually a vapor, which is a gaseous state of something that is normally a liquid or solid. So
And a key point of the actual gas definition is that it's naturally in gaseous state.
Yeah.
yeah,
That's why steam can't be a gas because it's not naturally
Yeah.
a gas.
It's
It's
not
normally a
naturally a
liquid
gas.
that became a gas.
yeah, I think I said that, but okay.
He did yet?
Right.
Oh, okay. One thing that she also made us draw a chart, and the chart says basically like solid, the shape is definite, the volume is definite, but it's not compressible. Liquid, it fills the bottom of the container. It is the volume is definite, and its compressibility is basically no. And the gas, its shape is it fills the entire container. Its volume fills the volume of the container, and it's compressible, very compressible.
You want me to add that table in the notes?
Yeah.
Yeah, just create a new table in that.
Alright.
When are you guys releasing the review sheet, by the way?
Oh
We're
no,
working on it right now.
we're working on it right now. It's on the community.
Yeah, the review sheet's already
okay.
been released.
We have like I think 15 people working on it right now. Some
Technically, like only 4 people.
probably
The
like
rest way more
12 of them.
as
but,
usual.
yeah, a lot of people are working on it.
A lot of people are just standing there doing nothing.
Yeah, there are a few idle people who are just looking at it to study.
So how do I work on it then?
Quite a few.
Just click on the link on the community and you'll be able to edit.
Oh, by the way, guys, these resources are only for the IB. If you guys aren't from here, you won't be able to know whatever the crap we're saying. Sorry.
I don't know what you're trying to say.
Wait, what happened? I'm confused what you're talking about, Matt.
Wait, what?
Everyone in this community is in IB.
Yeah.
Okay.
Yeah, but there are sometimes viewers from other places that come looking over this.
Oh.
Oh, okay.
Alright, it really doesn't matter.
Alright, so next I'm going to talk about mixtures. Mixtures, they're pure, both pure substances and mixtures are all matter. Mixtures retain both their individual both the individual properties of the components. So one example would be salt water. It's still salty, and it's still watery.
Technically, salt water is a pure substance.
So you would say it was an aqueous mixture because it has water in it.
Remember the 2 different types of mixtures, though, homogeneous and heterogeneous?
Yeah, I'm getting that.
Homogeneous,
Alright.
heterogeneous.
So there's 2 different types of mixtures, homogeneous and heterogeneous. Homogeneous mixtures look the same throughout, and you can't see the individual components. So the example was salt water. You can't like tell which is the salt and which is the water. And they're also called solutions. So homogeneous mixtures are also called solutions.
Okay, wait.
Also remember,
Can I ask a question right now?
Yeah.
So for homogeneous mixtures, homogeneous whatever, like if you didn't know what's actually in it, and suppose it was just like flour and like salt, okay, and just by looking at it, it's the same color and everything, okay.
Yeah.
So would that be still be considered a homogeneous mixture, or would that be considered a heterogeneous?
well, one more thing you could remember to classify that is homogeneous mixtures are pretty much almost all the time
Yeah. So like, if, for
having.
example,
They're all the
I'm
time.
kind of late in finding these people who want to be in here and talk, so it's kind of embarrassing.
one example would be like Gatorade. Like if you put the powder in, then it fills the entire bottle, and you can't tell like which is the powder anymore and which is the actual water of the Gatorade. So like that would be
But that's like salt water.
No, yeah, that's if you were to split it in half, it should have an equal amount of of all the substances in the top half and in the bottom half. That would make it homogeneous.
Oh, okay.
Yeah, that's what I was saying.
I have a question for like that powder thingy, for Gatorade. If you evaporated Gatorade, would the powder still be there?
It would
Probably.
be like left in the
Because
I
bottle.
wouldn't say so. It would be it would be in syrup form.
Yeah, because
if we were to
there's
evaporate
stuff
it,
in
Well,
the-
it would be
it would be a
no
syrup.
evaporated
Gatorade.
Gatorade. It would probably still be in powder form. Just
If you evaporate something
most
like
of
sugar,
the
If you evaporate, yeah,
things
it's still
inside
gonna
would be expelled.
There's no chemical change that goes on in there, so it's gonna be a physical
yeah,
change.
it's basically diluted sugar and evaporated. Usually, what you'd find left is the sugar.
Yeah.
All right.
The food coloring, probably will be evaporated though.
Yeah. Next is heterogeneous mixtures, which are they look different throughout the entire thing. They're either layered or you can see the individual components. So one example would be sand and water or oil and water. Like with oil and water, if you put the oil inside the water, then you can like the oil rises to the top and you can see the layers. So you can see that the oil's on top and the water's on bottom, and you
Like
can
the oil
see the
is-
individual layers of the mixture.
I don't really think oil is denser than water. I'm pretty
Less
sure
dense.
that they're different.
Yeah, there's a different density between both of them.
Oh, so either way, but you can
I
tell
thought
the
it's just
difference between which one's the
concentration,
oil and
but
which
it
one's the
wasn't, like,
water.
enough to
Um,
or anything.
And that way, like that would be a heterogeneous mixture.
All right, I'll do the next part, the examples of the solutions.
Yeah, you
Thank
can.
you.
So I think this was in the book. I'm not sure about that.
No, we took notes over it in class, so.
Yeah. No, this the chart that we had, the gas, liquid stuff.
Yeah, that was in the.
That was in class.
Okay. But
Yeah.
so this is just some examples of like types of different solutions for two types. So gas is the air you breathe because it's like nitrogen and oxygen combined. Then you have gas liquid, that's just air with droplets.
Oh yeah.
Liquid gas is sodas.
Isn't it the other way around?
The word that comes before is the one that has more dominance.
A really concrete example of a solution would be like a solid, like salt or sugar mixing into a liquid solvent like water.
Yeah.
So salt water. You mix solid salt into water.
Yeah,
you get
pretty
salt
much.
water.
That's a solution. Yeah.
He was just saying sugar.
Yeah, like the part that Arjun's talking about, Miss Day in 7th period hinted that would be pretty important.
Yeah.
What? Wait, which would be pretty important? Can you?
The solutions, the
Solutions?
gas, liquid.
Okay, cool.
Yeah. So just remember that the first word is the one that's more dominant and will be more present in the thing. For example, gas liquid is air with droplets, whereas liquid gas is sodas, where it's the opposite. And there's gas bubbles inside the liquid.
Yeah.
Liquid is a combination of two liquids, a solution. So that's vinegar. And vinegar is acetic acid with water. Solid liquid, that's like Gatorade, the power drinks and all, powdered drinks. And solid liquid, Yeah,
that's
then
right,
after
solid
that,
liquid.
solids are just alloys. Like copper and bronze.
No, copper's an element.
Okay,
No,
what's
sorry,
the
sorry.
You
Yeah,
mean
yeah,
like
bronze.
iron and carbon?
Yeah.
iron from?
No, iron?
Yeah, iron and carbon make steel.
Oh, steel then. Yeah.
Steel is an alloy.
Bronze.
Bronze is an alloy.
Is that true?
Right. No, yeah. So is brass.
Oh, also,
yeah.
alloys are considered not mixtures, compounds, not elements.
Yeah.
They're considered homogeneous compounds. No. What am I talking? They're just considered compounds.
Okay. Wait, I have a question about
Okay, Tyndall Flat.
No, wait, Ryan, tell.
I have a question about like the dominance of a thing. When you say the first word has more dominance, I don't understand what that means.
He means like, okay,
It's
let's say
like-
there's a gas liquid. That means that there's more gas than there is liquid. So water droplets in the gas means that there's more gas than there are the water droplets. While in colas there's more liquid
True that.
than there is the gas bubbles.
Wait,
And
when
soda was a liquid gas.
Like cola would be a liquid gas because the liquid takes
Oh.
dominance.
okay,
And there's
yeah,
a few.
we switched those on the notes page, so I'm sort of like confused.
Yeah.
No.
Yeah.
Hey, is this little thing, the thing I was talking about, the gas liquid, is that on the review sheet?
It's on.
Yeah.
Yeah. It's
Yeah,
captioned in
it's
words.
right here.
Wait, so an example of a liquid gas is soda, and the gas liquid is water droplets?
Yeah,
Yeah.
that makes more sense. All right.
Okay, alright, got it.
Was there an example for a liquid solid?
Liquid solid.
Solid.
Yeah.
Iced water.
Do you mean like solid liquid?
Gel?
No, there wasn't. There was only liquid gas and liquid. There was
Yeah,
no
there was.
solid.
I
It
don't
was
know
a solid liquid though.
solid.
There was
there's
gas
a solid
too. There's gas too. Remember that?
Right.
Yeah.
Yeah, that's just air.
Yeah, there's no.
Oh, wait, hold on, I have notes. Wait, did you say solid liquid or liquid solid?
There's no such thing as a liquid solid.
I said no.
Okay.
We haven't. She didn't put any liquid solid on.
Yeah, there was a solid liquid though.
Powder drinks.
So, do you guys know any examples for a liquid solid, or is that
I'm looking
like,
some
I
up
don't
right
think that exists.
No.
I'm pretty sure
Maybe-
they do exist.
maybe,
because,
like,
as I
gravel
said, it's
in-
dominance. So
Or wait, maybe like sand and water. Huh?
Or ice water.
Yeah, ice water makes sense.
It says
ice
drinking water
ice
with
water would be.
Yeah.
Like, I think it's talking about it's like in its natural state.
Yeah, so ice in its natural state would still be waters.
Yeah. All right. Okay, who wants to do Tyndall effect?
Tyndall effect is essentially if the particles catch the light.
Well, if you can see the light going through.
It helps tell if it's a colloid or a suspension because
If it
colloids have
scatters the light at
smaller
all.
particle sizes.
Yeah. You want to go over like which sizes lead to
Yeah, suspensions are the biggest colloids.
Largest, yeah.
suspensions show the Tyndall effect, colloids show the Tyndall effect, and solutions don't, right?
Yeah.
And what's
Here
the
on
order
the
and like
cover
what's
sheet,
the greatest?
So you see the colloid, you can see the light, and when you see the light, it's basically in the solution, the light's reflecting you, therefore your eye.
You have to
And
look
that's
and see if the light
scattered.
goes through or not.
Yeah.
So if you can see the light inside the solution, then it's scattered. And then you see the Tyndall effect.
So colloid, substance, and colloid and suspension, like which one's bigger? Which one has bigger
Suspension.
particles?
Suspension has larger
So
particles.
suspension, then
Yeah.
colloid, then
Colloid's like kind of in the middle, and then solution, it doesn't scatter.
An example of like a suspension. Remember our project where we had to work with zinc? Zinc would basically be a suspension in that time. 'Cause
There was also the one test too with like the bunch of like dirt or whatever.
yeah.
yeah, or that one.
All right. Separating mixtures.
Distillation and shit.
Very good, Michael.
That's how I've stopped caring.
In live, oh my god, man, in live stream too.
But yeah, make sure you
There'll
bring
be
chocolate.
tens
You don't
of
wanna
people who are watching this. Don't you feel shame?
How many people are watching the live stream?
be like 8.
Okay, so
But for like,
separating mixtures
if
can
we
be
keep this
done.
up for like the next 4 months, there'll probably be like 400 views or something.
Or like 10.
Yeah.
Don't
So I can do separating mixtures.
Yeah, if you want.
Okay, so separating mixture is going to be done 3 ways. You can consider it 4 if you separate distillation and evaporation. So filtration, chromatography, and distillation. Basically,
Those are the main 3.
yeah, those are the basic things on the review packet. So filtration is passing it through a filter. It can be through an air filter or through a water filter. Just note that, that's important. Chromatography is basically the separation of it when the mixture is carried by liquid or gas. So, like the chromatography paper we did, the ink was carried by a liquid across the paper. So, thus forth, we get the different chemicals that were in the ink.
The science behind this, if you've like answered the analysis questions for it, is that the different colors of inside the ink are actually different sizes of particles. So that the heavier particles and therefore the related color or the RF value is larger.
Oh yeah, make sure you know how to calculate RF.
And
that
then
way
we
you can
have...
explain why you see.
Wait, how do you calculate RF again?
It's the total, the distance to the solvent divided by the solute.
Yeah.
So the water divided by the ink.
Okay, then we have like distillation and evaporation. So separation by boiling, pretty much, and it's the different boiling points that separate the 2 liquids and solids. Basically, water has a separate boiling point than what, you know, oil. So one of them's gonna be left when the other one evaporates.
Left behind first.
Yeah.
Yeah.
General gist.
And then make sure you like the formulas that we did. We only did one, like distances, right? Density is mass divided by volume, but make sure you...
Yeah, we can talk about the guess method later as well.
Yeah, someone, I don't remember. Actually, you guys want to talk about the guess method right now?
Sure.
I guess. Alright, so like, G means like what you're already given in the problem.
Right.
Oh, hello?
Okay. U is like...
U is the unknown.
Yeah, yeah, sorry.
One second.
U is what is unknown, which one
E is the equation, S is the
Someone type that up.
substitution, and the final S is the solution.
Wait, what are we on right now? Sorry.
Guess. The guess method, G stands for given, U is unknown, E is...
Has someone written that on the thing?
I'll start doing it.
Alright.
Guess method.
Where should that be under, though?
Keep it at the top, above sig figs. Like, in big letters so no one forgets.
Alright.
Yeah, because knowing Miss Day is probably like a short answer question, but she'll give you like 1/10 of the point if you don't use the guess method.
True.
Oh my god, she's gonna kill us.
Do the short answers again.
Did she tell you guys that all of the points added together was only 99?
What?
Yeah.
1 point for writing.
Wait, so can we or can we not get 100?
You can. You have to. She gives 1 point for writing your name.
So you started
That's
at 1
ridiculous.
unless you forget.
I never
Are
do
you
that on top of it. I never write my name, Christ.
So you
Or just make sure you do.
That's our curve, basically.
Okay, really? Really?
1 point curve, yay.
Amazing.
better than nothing.
He's got a point.
Oh, did we go over the guess method already, or?
Yeah, we
Yeah,
did.
we just
That
did.
was like 2 seconds ago.
Do you want to like do a practice or something, just like one, just to make sure you understand it?
We don't have like a whiteboard or something we can write on.
Yeah, we do.
That's
Yeah, I do.
Draw. Can you share the draw thing?
Probably.
Here. And I must.
Yeah, just use the group board app. I think that'll work.
Yeah, that'll be fine.
Yeah.
Oh, okay. So wait.
Hey,
You guys have the group board app open?
Yeah, how do
I have
you
it.
actually get to the document? Could someone share that with me or some shit?
There's a link
it's on
on
the
the
community.
community. Oh, if you want the link to the thing, I can send it to you.
Yes, please, that'd be nice.
Just post it on the group chat.
Okay, it's on the Inside
Yeah, it's
share.
on there. I posted it a while ago.
Alright, Michael, just look for it.
There you go.
Do you want me to write one down or?
Okay.
You should be able to
there I am.
access it.
Okay.
Cool.
Yeah, I'm there.
Welcome to the dock.
Okay, so who's gonna start writing the question?
Okay.
Who's playing like ukulele in the background?
There's a.
There's a hippie on this line.
Sorry.
Yep, exactly. There you go, hippie. Oh god.
It's Brian.
I was playing it lightly. I do it when I'm like really tired, so I
Yeah.
don't.
No problem.
You're like the
Do
Zach.
you live in a truck, Ryan?
Yes. Very moist in here.
You live in
Yeah,
a
I bet it's
truck-
really got really sexy in there, didn't it?
Yes.
Mm.
Michael, can I say one thing? You're
What?
being recorded. It's on
Yeah, I
YouTube
don't-
right now.
Yeah,
I
what?
don't care.
You're saying. Alright.
I don't
And the
care.
save will view you later.
Oh
Yeah,
God.
I still don't care.
Alright, whatever.
Okay.
I can say 5 words and the NSA will immediately go search up this video.
Okay.
Alex,
Matt, you can probably just say there were 5 brown people and
Bob
NSA
Cherry.
will go switch up the video.
Am I the only white guy here?
True.
Probably, yeah.
Am I?
Steve
Yeah, I
White.
am.
Yeah.
Oh, cool.
Is it Steve White?
We should get back to.
Yeah.
We
I
should
was
get.
supposed to in the beginning, but he just had to help this get set up.
Wait.
Alex up to this.
Starting the review, or working on the review.
Hey guys, this Alex, the Google Science Fair winner last year. I think you should harass him.
If you guys wanna leave,
Okay, what are we on next? Scientific notation guess method.
I'm
we
good
have-
to
You
stay.
get the guess method?
I
Yeah.
have no reason to leave.
it's just that we have a majority of the stuff covered. So if you wanna like leave it, or if you're in a hurry, you can leave.
I'm
No,
good.
I have time. I have till like midnight.
Okay,
It's 10 till
because
3
I'm
anyways.
pretty sure we got
know.
most of the stuff covered. I think the next part we should go over is the actual book.
The book.
The
There's
chemistry
nothing useful in the book. You
Really?
All of
covered
us
it all
read
pretty much.
chapter 1 though.
Yeah,
no,
because
like I'm not
told
saying
us
any
to-
new
no, no.
stuff. It's just gonna be like a good review. In there.
There's
Maybe.
really not anything in chapter 1. I have the book in front of me right now.
yeah.
You find
So,
out that
yeah,
the best
it's-
way you find out that the best way is the studies that when
Pretty much all you would ever
finding out
find
random
is
stuff that relates to this.
chapter 2.
So like somebody further explains it helps them.
Okay, so can everyone on the Hangout chat? Can everyone start up the group board app?
The what app?
Group board.
Group board.
Wow. Okay.
Go
Okay.
for the more apps thing, recent, and just click
I
the
found it.
add apps, and get group board.
Yeah, I already have it.
Yeah. We're creating a little guest chart on there, but after we do the do a quick practice on the guest method, we can do a few practice questions.
Is that like
I messed it up.
Just click it, it's the one with the globe.
Oh, we're just writing stuff.
Oh,
It's not a globe. It's this weird car kind of.
It looks like a globe.
Oh, this is yeah.
Oh yeah, okay, that makes sense. Thanks, Atulia.
Of
Okay, guys.
Who's drawing random lines on it?
Wait, share this thing. You screen share the Hangout.
Okay.
Group board.
You can work group board.
Group
Thank
board.
you.
Yay.
Continue.
Okay, so this is the get this. will
No,
be the guess method.
no. Stop running an eraser through it.
Loading.
Thank
What
Yeah,
a-
it's taking a long time to load.
Yeah, I just started it
Oh, no.
up, so I'm fine.
Okay, so this is the guess method. It means given unknown, estimate substitution and then solve. So basically, we'll be given a density or a time question or some distance, right?
yeah,
Time,
this
some
most
stuff
likely be on
easy.
the short
Then,
answer portion.
Yeah.
And void
then
will
we
probably
put
be half.
given stuff on
What's
here,
gonna be the
unknown
short
stuff here, and then we estimate what usually should be on here.
Atulia, what'd you just say?
This is she said this is most likely going to be in the short answer part where you have to show what you
No, she told our class there was going to be 3, I think.
Yeah.
That are just guess method, and they're going to have the box, and you're going to have to fill it all in.
Alright.
So just know how to do.
Yeah, there can
Let's
be 3
create
short answers
questions
which are
guess
guesses.
Oh wait,
Short answers are either going to be fill in the blank or calculations or occasionally matching, like one
You
or
might
two.
also have to know conservation math because we did a little bit of practice on that in class.
Did we?
Remember about that.
Hey, can I ask one question?
Yeah.
Did we go over intensive and extensive?
I can do that right now if you want me to.
Sorry.
Matthew, can you add Francis? Francis says he wants to join right now.
Testing?
He's a bit late, but it really doesn't matter.
Ryan, do you want intensive extensive right now?
Let's do it after we're done with the guess method. So there's
We
not
can
too
do it
much.
like really quickly because it's like really simple.
Yeah, it's fast. I can do it now.
Okay.
Okay, so basically extensive is a property that changes when the size of the sample changes. So like mass, volume, length, and basically
Okay.
total change.
Hey, did we go over physical and chemical change?
No, we haven't yet.
No,
Let's do this
Okay,
first.
we'll go over that next.
Yeah, okay, sorry.
Stop running erasers through my beautiful box.
Yeah, so what Michael's saying is right, and just make sure that you know that density is intensive.
Yeah, because density doesn't change with size.
Yeah.
Yeah, intensive property is basically bulk and it doesn't change by the physical property.
So
That's,
extensive is the one that
We
does
can take
change
a picture
with
of
the
this, can we?
size.
Extensive change with size. Intensive,
Does not.
yeah.
So I would
pretty
remember
much.
like extensive is kind of like extending, which is length.
Or
Yeah.
intensive is
And
irrelevant.
intensive is like, for example, a concrete example is like temperature.
Or
And
like
its refractive index and stuff like that.
usually color works too, right?
Yeah, color, density,
odor,
hardness.
luster, malleability, ductility, conductivity, hardness, melting/freezing point, boiling point, and density.
Thank
and
you.
huzzah. Pretty
Alright,
much.
I was really confused about that for some reason. Thank you.
Yeah, no,
And-
make sure you just read over like the colloids and solutions and stuff, because that's probably going to be the most part of the test.
Yeah,
See
that's
that already?
really
Highlights
important
and
actually.
suspensions.
It's really important.
Wait, what is?
Basically what we have to know is homogeneous mixtures, heterogeneous mixtures, solutions, colloids, and suspensions.
Okay,
Those
so
are going to be really
someone
important
say
because that's
what-
like half the lesson.
Oh, okay. No, I already know. We already reviewed that. Alright, cool.
Yeah, you're good on that.
Which two things are pure substances?
Elements and compounds.
Yeah.
Yeah.
Here's how it is.
What happened to the font on the chemistry matter guide? And it's like only 99 points. What a genius! Really small.
Matter guide. Where's that?
You should put the headings in red actually.
Yeah, often that's
That'd
just
probably be a better idea.
You shift D
Right.
fenestration.
Yeah, if you can do that for us. that'd be-
Yeah, I'll do that right now.
Alright.
That's great.
Oh no, I got a cold. Damn it.
Red. Folded.
What else do we still have to go over?
Lots.
Isn't chem change?
Actually, we're pretty much done for the most part.
Really?
Yeah, there's not that much
Yeah.
to learn. Yeah, she's a bad teacher. And she,
Fun fact, what does defenestration mean? Everyone
throwing out a window.
Defenestration means to throw out of a window.
Yeah.
Yeah, to throw someone else
Oh, yeah, that-
Enforcement unit.
Defenestration of the fan.
Yeah, from Euro.
have the Euro like act skit thing
Yeah.
tomorrow.
I told you it
Oh.
wasn't necessary to type that in.
Euro's like a love-hate relationship.
I
You
love
hate that. You hate how he majors in 3 days, but you love how the grade's still keeping you afloat, even though like you're failing to other classes.
Yeah.
And the grades don't
Well, it's not
come
mine.
in until he gets too lazy to actually give us a test.
I'm not even taking Euro.
Are you guys seeing the screen share of
Yeah,
this one?
yeah.
Okay. Do you want me to actually like go through it?
Sure. Dude, this
well,
is
yeah.
not that hard though, so whatever.
Okay. All right.
You do so much.
Oh yeah, hey, one important thing about the guess method is you have to make sure that your solution has the units on it, because I feel like she's gonna count up a ton if you don't.
Yeah. Obviously.
These are probably gonna be the free response questions or whatever they're called.
Yeah, definitely. Short answer. She said that any math is gonna be short answer.
Alright, that's gonna be easy then.
Your guys' colloid section like fell out of the bullet, so I just put it back in.
Thank you.
The mass and the volume, and you want to find out the density.
Can you guys see my combos?
It's not estimate, it's equation.
Oh, sorry.
Sorry.
Do you guys want me to put sig fig rules on there? Because I have those all ready.
Yeah,
I
make
think
sure
what you got
Yeah, just put whatever you have on the thing that we didn't already put.
No, you got them. Never mind.
make sure that you know that addition and multiplication have different rules.
And you might have to
Michael,
do the
basically
equation.
go through the review and see if there's something that you feel you want to add.
Yeah, because that's something our entire class missed. Is that addition you have to round to the
Least accurate.
least precise decimal. But multiplication you just round to the number of sig.
Multiplication and division.
Yeah, multiplication.
Hey guys, do you want to do a hangout for the Euro test, the World History test, and the pre-cal test?
Not all at
On
once.
Monday, Tuesday, and Wednesday?
Wait, what's on Tuesday?
Tuesday hangout because your test.
Someone's writing the same thing as me.
Yeah, and then like Sunday hangout for the World History test.
And pre-cal.
Yeah, I'd like to do that Sunday.
Pre-cal's kind of meh.
Yeah,
You guys sure you want to hang out on pre-cal?
No.
The only thing we need to really memorize on is the unit circle, which is extremely hard for me until I finally.
The unit circle wasn't that
So I
hard.
kind of figured it out.
Oh yeah, you're supposed to try to do all the quizzes, like even the open note quiz, you should have tried to do it without using your notes. That makes it easier to memorize.
Yeah.
Even Shadowlon found like patterns to it, so I kind of get it. I just need to memorize the pattern, which is like only 4 things. So that.
Oh, here's an easy way to do it. If the 3's can't be next to each other, so if it's pi over 3, the x value cannot be square root of 3 over 2.
Is this turning into a pre-cal hangout?
If it's pi over 3,
Yeah,
it's like
let's keep Chem
3
going,
over
guys.
2, and
The
then
x value
guys.
is 1/2.
Guys,
and one value is
continue
Guys,
with
this is Chem.
Yeah.
Come on, guys.
For the pi over 6.
Talking about physical change and chemical change. We know So what's the difference between physical change and chemical change?
Physical change changes either the shape, size, or color.
Physical can be determined.
It
Chemical
doesn't.
changes the composition.
So, you can change physically the form of it, so you can turn like a chemical liquid to a solid. That will still be a physical change.
Yeah, like you can melt like iron and it would turn into like ore.
Liquid
you
form,
can-
then it would
that's
still be
still
different.
physical because
If
you're not
iron
actually
turns
changing.
into ore, it's physical
So
change.
you're
It's not
basically
chemical
just
because it's not changing anything in the actual chemical.
Yeah.
It's still the same, it's just changing states.
Because you can change it
Until it
back.
reacts with something like oxygen, it's not
To
going to
be a chemical change, it has to change its actual formula.
And it has to be unreversible.
Yeah.
So like
All of this
like
is
when we eat
complicated.
food, the transformation of the actual food into energy,
Yes.
that would be considered
Chemical.
And then for like
It's
a lab,
chemical change.
Because you can
Just
revert all that
Basically,
energy back.
all you have to know is chemical changes change the chemical formula, and that's like if there's any question on that test, it's gonna have to be that, and it's gonna show you the formula.
Yeah, it's going to really point it out at you.
another example is like the burn magnesium and hydrochloric acid, right? Because
Yeah.
Yeah,
it's spark.
yeah.
It was supposed to burn, but it didn't. Not burn, bubble.
bubble. Yeah.
Yeah, but after it's been mixed and burnt, you can't return the magnesium back to its original form.
I'm pretty sure though. Watch out, because if she asks this, she's a bitch. But but watch out for this, because she might ask you, what is the reaction when the magnesium burns, physical or chemical, and that's chemical.
They're
Because you're
not
mixing.
the questions on the
Yeah,
test.
because any burning
Yeah,
is
I know, but if she asks that, that's not exactly lab specific.
I'm
True.
pretty sure she said in some period that
It's
there's not going to be a
chemical
question about
because
the
basically
labs.
it's mixing carbon, heat, and magnesium. So watch out for that. And
Okay.
no,
and
basically,
because it releases hydrogen and stuff. For burning the magnesium. Not the first time, the second time when you had to put like the pipe inside the test tube.
Oh, I can copy
and
this.
know like your basic chemical formulas. Like I don't know if you guys read the book or not.
No, it doesn't.
Oh yeah, know
But,
your
like,
basic elements.
Yeah,
Nobody will ever
Like
bother.
Like-
aluminum,
no hydrogen, helium, water, and shit.
aluminum.
Yeah, but we're
Yeah.
gonna have a chart. She's
Yeah,
gonna
but
give
the
us a
chart's not
periodic
gonna
table.
have
with
the
the
Know
chart.
know most of your noble gases. You don't have to know all of them. Know the pertaining ones to this lesson.
Wait, what?
Helium.
Noble gases, like the final.
Wasn't there something special
Like
about
krypton, xenon, stuff like that.
Here's this.
Neon, krypton, xenon.
And no,
Helium.
no pertaining metals. Like you don't have to know.
You don't have to know the 7 metals, which is
Yeah, you don't have to know the 7 metals. You don't have to know really, really complicated stuff. You don't have to know the ones that we made, pretty much. What can I say? Like, know your basic elements. He gave us a periodic table for a reason, I guess.
you might need to know what chemical stability is.
For the test. It's gonna be in our folder, she said.
Oh.
No, but it won't have like it doesn't have the names on it. It just has the symbol.
Yeah,
Matthew, if you
Yeah, but it's
you wanna
pretty
get
easy
that-
to figure out what the name of it is.
That's iron.
From the symbol.
and there's like a huge periodic table in the back of the room, so.
Yeah, I mean, like, she may or may
She's
not
probably
cover
not
that, but if she
gonna cover
doesn't,
No, she
fine
won't
then.
cover it.
There's a sub, so she's probably not gonna go through all that trouble.
Matthew,
Yeah,
no, Matthew,
I don't even think she's tall enough to cover that.
press the search button, or like press the Windows button, and then press snipping tool, and then just
Potassium's K, iron's Fe. Everything else is
Can
self-explanatory.
you repeat that?
open your Windows start menu thing or your search, and then type in snipping tool.
Oh
Yeah.
yeah, thanks.
That's how I take
I
all
forgot about that. Because
Right.
everything
Guys,
takes
for your
so long to
colloid
load.
section, you don't need this whole thing. It is homogeneous. Colloids are
By
homogeneous
the way,
mixtures.
Matt, you need that sniffing tool for
No,
your
they're
video.
not. Colloids are heterogeneous. Solutions are homogeneous.
Yes, yeah. Hold on, I'll check.
Colloids are heterogeneous. Solutions are homogeneous.
Colloids aren't heterogeneous, are they? They're like borderline.
No.
Right? Okay.
Yeah.
What would the defenestration on this?
Wait.
Colloid is a homogeneous solution with intermediate particle size between a solution and a suspension. Okay, so yeah.
And
Alright.
what's heterogeneous?
Those are just the ones that like you can clearly see
Like,
separate layers.
Basically-
are there smaller groups inside heterogeneous?
So basically
One,
homogeneous
I think.
homogeneous are like where you can't see any clearly defined layers.
Okay, so is a colloid a substance and a suspension? A
Colloid-
colloid, a suspension, and a solution, which
Colloid,
is
okay,
homogeneous.
hold on. Homogeneous mixtures, which are also known as like solutions, or not also known as solutions, but they have like 3 classifications: solution, colloid, and suspension, and that depends on the Tyndall effect.
Yeah, but which one is homogeneous?
Okay,
Are all 3 of them
1 second.
homogeneous?
no. Suspension and colloids are usually homogeneous, or solutions are homogeneous. Colloids are borderline, but they're usually homogeneous. And suspensions are heterogeneous, or whatever it's called, because you can see in a suspension because of the large particle size.
Suspensions are always going to be heterogeneous.
Yeah, and solutions are
I'm pretty
always
sure.
homogeneous.
Colloids, I think you're right. They're borderline. They're more homogeneous.
I remember reading borderline in the table.
Yeah, it was borderline in the table. That's why I'm
Oh,
Yeah.
homogeneous.
okay, that makes more sense. Yeah, that's my bad.
But suspensions are always suspensions are always
Suspensions are always going to be heterogeneous.
heterogeneous, right?
And then solutions
Is
are
it
always
heterogeneous or heterogeneous? I don't care. Either way.
It really doesn't. She's not going to ask you to say the word on the test.
Dude, what if she does?
She won't.
Yeah, the
I
sub's
hope
gonna
she
judge
doesn't at
you.
least, because I'm going to
Amazing.
fuck up.
Dude, even the Spanish teacher doesn't go through that much Bible. We have to
Yeah.
The teacher doesn't teach, so.
Actually, Papillon does teach you safe part.
to some extent.
Yeah.
That was our class.
Is that it?
Yeah,
Yeah, I'm
Um,
pretty sure that's it, guys.
Let's see.
Oh, wait,
Learning
wait,
guide. What is this
There's a
here?
chemical
Learning guide,
properties
problem
thing.
bank, safety guidelines.
I'm
She's
not gonna be
She
actually
probably
no.
won't ask that.
Just
We have to go over
erase
to
those
look
things.
over those.
We're just gonna go over it, but
Like for
Just
safety.
erase those titles. We're not gonna do that.
No, well, if she
Yeah.
if she puts safety symbols on there, do you guys want me to post a picture? Because I have a picture of the required safety symbols, pretty much.
And no.
No, how
They're
about
like really
that?
simple.
don't put the
so-
required safety symbols. Put the ones that feel a bit more discreet, like you won't know them. Like the one for goggles is kind of self-explanatory.
Yeah, obviously.
Yeah. So
Hey,
just
wait,
put the
alright.
ones that you feel that are a bit harder to find.
I doubt
Um,
they're even gonna be on there though.
Yeah, they probably won't be on there. Just erase this whole part.
Wait, can we use a tiny URL? Would it work if we tried to type it in afterwards? Because it's really annoying to type in the really.
Hey,
What is this learning guide thing?
We're just gonna go for
We
it.
need
but
to go
we don't
over
do it.
physical chemical properties. Hello?
Yeah, that's what I was trying to say earlier.
What'd you say? Yeah, we did, Ryan.
Physical and chemical
I
properties.
think-
We already did go over that.
Did we go over change of properties? Because I'm a
We
little.
didn't do either, I don't think.
They're both basically the same thing.
Wait, what's can you explain the properties? I know the change. I just don't understand properties.
Properties are basically like physical properties would be like things like color.
State of matter.
If you can
Yeah,
test it
it's
without
better.
changing
Ryan,
the substance.
let's make things easy. Let's make life easy for ourselves. Physical properties, things you can see. Chemical properties, things you can't.
Fair enough, yeah.
Oh, okay.
Basically,
That
yeah.
just makes life really easy for you.
Yeah.
Chemical properties can only be
Life
determined
is never
by
easy,
changing the
okay?
identity
Let's just
If you
get
want,
it
like, if you want the scientific, like, whatever definition, physical properties, you can observe them without changing the composition of the substance. But for chemical properties, you actually do have to, like, reaction with
Yeah.
acid, burning it, or decomposing or oxidizing.
Do you guys remember the little Venn diagrams you gave us about metals? The properties of metals and non-metals? And
No.
Dude, that's self-explanatory.
Oh, yeah, I have it right here.
Metals
You want me to,
Odds
like,
are that won't be on there. No, odds are that won't be on there.
Yeah,
but
but metals are conductive and malleable. Because
and they
they're
have
metals.
lost.
metals are
They
reactive
react
with
with
acids,
acid.
but non-metals are not. Just make sure
You
that.
know which metals are pretty much malleable.
Yes.
Do you know
thank
the
you,
order of
Michael.
metals, guys?
Metals are on which side of the stair step?
Left.
Wait, how would you not know that?
Who was Steve?
I know, I just asked a question. Like, it wasn't supposed to
Metals
be.
are on the left. Metal
Yeah, who the hell is
on
Steve? I've been
staircase,
wondering that the
and
whole
to
time.
right
Who is
of
Steve?
the
Steve is
non-metal.
Christopher.
Chris Whitman.
Oh,
Steve.
that's
Steve.
for the one that from tennis,
Steve.
right?
I know who you are.
Oh, lol. So,
Wait, wasn't that Eddie?
Michael, you're not the only white guy.
What was,
Okay,
Who's the ghetto singer? Stop that.
I am so ghetto, guys. Am I the ghetto singer? Yeah.
No,
I will kick you out.
if not.
So ghetto. Ghetto.
So, does anyone want to go?
Stop it.
Really good.
Is there anything that's left that we haven't gone over?
Nope, that's everything that
Yeah.
I thought of on my learning guide as well.
Yeah.
Okay, you guys want to conclude?
Yeah, I think we'll call it now. That was a good hangout, guys.
Yep, let's call it quits.
Yeah. Alright, see you guys.
Call quits
Good
again.
night, guys.
Let's hope everything we start
luck on
for
the
beyond
test.
time.
Yeah.
I don't want like an ice bro.
We're just alright. See y'all.
Oh, by the way,
Bye.
Bye, Ryan.
I found the kid who I'm gonna give all the biology reviews.
Matthew's gonna like sell them to him for like $6.
Good job. Make a profit.
See you guys. I stopped the broadcast, right?
Yeah.
Yeah.